Pop quiz. What's the strangest thing your brain does? You might say dreaming. Your consciousness generates entire alternate realities while you sleep. Weird, definitely. Maybe you'd say forgetting. Your brain decides some memories aren't worth keeping and deletes them. Frustrating. Or perhaps hallucinating when you're sleep deprived. Your brain fills in gaps with things that aren't there. Disturbing. But none of these are as fundamentally bizarre as déjà vu, that moment when reality glitches, when you're absolutely certain you've experienced this exact moment before. Same conversation, same place, same feeling. You know what's going to happen next. Except you don't, because it's the first time. But it isn't. But it is. Your brain is telling you two contradictory things simultaneously. This is new. This is familiar. Both feelings are equally strong. Both feel completely true. And for a few seconds, you exist in a cognitive paradox where your sense of reality fractures and you genuinely cannot tell if you're remembering the present or experiencing the past. This happens to about 70% of people, most commonly between ages 15 and 25. It lasts a few seconds, then it's gone. And you're left wondering, what the hell just happened? Did you see the future? Did you live this moment in a dream? Are you in a simulation and it just glitched? Or is your brain malfunctioning in a very specific and deeply unsettling way? Spoiler alert, it's the last one. Déjà vu is a brain error. A fascinating, complex, thoroughly studied brain error. And what it reveals about how your brain works is way weirder than any supernatural explanation. If you want more videos about your brain lying to you in creative ways, hit that like button and subscribe. Because déjà vu is just the beginning of how unreliable your perception of reality actually is. This is a neuroscience dive. Blah, 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 we're going into your temporal lobe. We've done this before. Let's find out what déjà vu actually tells you about your brain. Historically, well actually, neurologically facts, part 1. Before we talk about what causes déjà vu, we need to understand what it actually is. Because the experience is consistent across people. You're doing something normal, having a conversation, walking into a room, watching TV. Suddenly, overwhelming familiarity. This exact moment has happened before. Not something similar, this exact scenario. The person said those exact words. You were standing in this exact spot. The lighting was exactly like this. You've lived this before. Except you haven't. Your rational brain knows you haven't, but your feeling is so strong, so visceral, so undeniable, you can't shake it. For a few seconds, you're trapped between knowing it's new and feeling it's familiar. Then it fades, and you're left confused. This is not the same as familiarity. You can walk into a coffee shop and think this place feels familiar. That's normal pattern recognition. Your brain is matching current sensory input to stored memories. This coffee shop resembles others you've been to. Similar layout, similar smell, similar atmosphere. Your brain recognizes the pattern. That's not déjà vu. That's just memory working correctly. Déjà vu is when the familiarity has no source. You're in a place you've never been, having a conversation that's never happened, and your brain insists you've experienced this exact moment. Not something like it. This moment, specifically. Precisely. And it's wrong. Provably wrong. But it feels right. That's the key feature. The feeling is disconnected from reality. Your memory system is firing familiarity signals without an actual memory to point to. It's a false positive, a recognition error. Your brain is saying, I've seen this before, while simultaneously not being able to produce the memory of when you've seen it before. Contradiction. Paradox. Cognitive glitch. The temporal lobe connection. Now, let's talk about where this happens. Your temporal lobe. Specifically, the medial temporal lobe. This is where memory processing happens, particularly the hippocampus and surrounding structures. These regions are responsible for encoding new memories and retrieving old ones. They're also responsible for tagging experiences as familiar or unfamiliar. And sometimes, they screw up. They tag something as familiar when it isn't. That's déjà vu. We know this because people with temporal lobe epilepsy experience déjà vu frequently. Right before a seizure, the temporal lobe becomes hyperactive. neurons fire chaotically, and one of the symptoms is intense déjà vu. The same brain region that causes déjà vu in healthy people malfunctions more severely in epilepsy patients. They report déjà vu episodes that are longer, more intense, and sometimes accompanied by other distortions: derealization, depersonalization, time distortion. Their temporal lobe is misfiring, and déjà vu is one of the outputs. This gave researchers a clue. If temporal lobe activity causes déjà vu, then déjà vu must be related to memory processing. And the leading theory is that it's a mismatch, a timing error. Your brain processes the present moment through multiple pathways: visual information, auditory information, spatial information, emotional context. All of these streams are processed separately, then integrated into a unified experience. Usually, this happens seamlessly, but occasionally there's a delay. One stream processes slightly faster than the others. You perceive the moment, then a fraction of a second later, the delayed stream processes the same moment. Your brain receives the same information twice, slightly out of sync, and it interprets the second signal as a memory of the first signal. You're experiencing something and remembering it simultaneously. Except you're not remembering it. You're just processing it twice. Your brain mistakes the echo for a memory. This is called the dual processing theory, and it's currently the most widely accepted explanation for déjà vu. Your brain has a hiccup. Information gets processed through two pathways at slightly different speeds. The second pathway mistakes the first pathway's output for a memory. Boom, déjà vu. Your sense of familiarity is real. The familiarity signal is genuinely firing, but it's pointing at the wrong thing. It's pointing at something happening now and claiming it happened before. Your brain is confused, and you feel the confusion as déjà vu. The memory system malfunction. Let's dig deeper into how memory actually works, because understanding memory explains why déjà vu feels so convincing. Your brain doesn't store memories like a video recording. It stores fragments, pieces, sensory details, emotional tags, spatial contexts. When you remember something, your brain reconstructs the memory from these fragments. It pieces together the details, fills in gaps, creates a coherent narrative. This is why memories are unreliable. Every time you remember something, you're rebuilding it, and the reconstruction isn't perfect. Details change. New information gets incorporated. Memories drift. But your brain also has a recognition system. This is separate from recall. Recognition is the feeling of familiarity, the sense that you've encountered something before. It's faster than recall, more automatic. You can recognize a face without remembering where you know them from. You can recognize a song without remembering the title. Recognition is a shortcut, a quick check. Have I seen this before? Yes or no? And usually, if the answer is yes, your brain can then search for the actual memory. But sometimes, recognition fires without a corresponding memory. You feel familiarity, but there's nothing to remember. That's déjà vu. Recognition without recall. Familiarity without memory. This happens because recognition and recall use different neural pathways. Recognition is handled largely by the perirhinal cortex. Recall involves the hippocampus. These regions communicate, but they can malfunction independently. Déjà vu is when your perirhinal cortex says familiar, but your hippocampus can't find a matching memory. The systems disagree, and you experience the disagreement as that weird split feeling. I know this, but I don't remember it. Contradiction. Your brain is arguing with itself, and you're caught in the middle. There's also the possibility of a recognition overgeneralization. Your brain stores memories as patterns, not exact recordings. When you encounter something new, your brain checks if it matches stored patterns. Close matches trigger familiarity. But if the pattern matching system is too sensitive, it might flag things as familiar when they're just sort of similar to something you've experienced before. A new place that has elements resembling a place you've been. A conversation that echoes previous conversations. Your brain recognizes the pattern elements and fires familiarity, but the whole situation is new, so you feel déjà vu. Familiarity without an actual matching memory, just pattern overlap. Your brain's matching algorithm got a false positive. The hologram theory. Here's a weirder theory. The hologram theory. This is more speculative but fascinating. The idea is that memories are stored holographically, distributed across neural networks, not localized to specific neurons. When you remember something, you're activating a pattern across many neurons, and small fragments of the pattern can trigger the whole memory. Like a hologram where any piece contains the whole image, just lower resolution. Now, imagine you encounter a situation that activates a small fragment of a stored memory pattern. Not enough to trigger full recall, but enough to activate the familiarity system. You're experiencing something new that shares elements with something old. The overlap is small, not enough for conscious recognition, but your brain's pattern activation reaches a threshold, fires familiarity, but can't produce the actual memory because the activation is too partial. You feel like you've been here before, but you can't remember when, because you haven't. You're just experiencing something that partially matches a distributed memory pattern. Your brain is resonating with a memory without fully accessing it. That's déjà vu. This theory explains why déjà vu often feels dreamlike. Dreams are also partial memory activations, random neural firing that resembles memories but isn't coherent. When you have déjà vu, you sometimes think, maybe I dreamed this, because the feeling is similar. Partial pattern activation. Familiarity without full recall. Your brain, in both cases, is working with incomplete information and generating a strange hybrid experience that doesn't fit neatly into experienced or imagined. It's both. It's neither. It's a glitch in the memory hologram. Attention and prediction errors. Another theory focuses on attention. Your brain is constantly predicting what's going to happen next. It models reality, generates expectations. Most of the time, reality matches expectations. When it doesn't, you notice. Your brain updates the model. This is how you learn. But what if your prediction and perception happen out of sync? What if your brain predicts something, then immediately perceives it, but the timing is off enough that the prediction feels like a memory instead of a prediction? This is the attention-based theory. You're walking into a room. Your brain, working ahead, predicts what the room will look like based on context clues. Hallway lighting, door frame, sounds. Your unconscious mind generates an expectation. Then you step in. Perception matches the prediction. But the prediction was processed slightly before conscious awareness. So when conscious perception happens, your brain has already seen this. The prediction feels like a memory. You walk into the room thinking, I've been here before. You haven't, you just predicted it correctly. But the timing glitch makes the prediction feel like past experience. Déjà vu. This explains why déjà vu is often triggered by routine situations. Walking into familiar types of places. Having common conversations. Your brain is good at predicting these scenarios. It's pattern matched them before. So predictions are accurate. And if the timing is slightly off between prediction and perception, boom, déjà vu. Your brain predicted you'd encounter this type of situation. You did. The prediction was processed as past memory, and now you feel like you've lived this exact moment before. You haven't. You just have a really good predictive model, and it glitched. The split perception theory. Here's the split perception theory. Your brain receives sensory information constantly: visual, auditory, tactile. These streams are processed in parallel, then integrated into unified conscious experience. But the integration isn't instant. There's a delay, a processing window, usually around 80 to 100 milliseconds. During this window, your brain is stitching together the various sensory streams into a coherent now. But what if one stream gets delayed? What if visual information is processed, integrated into consciousness, and then a fraction of a second later, another sensory stream processes the same moment and feeds it into consciousness again? You'd experience the same moment twice. The second time would feel like a memory of the first time. But it's not a memory. It's just delayed processing. Your brain is experiencing the present in duplicate and interpreting the duplicate as past. This is supported by research on people with split brain patients, people who've had their corpus callosum severed. The connection between brain hemispheres is cut. and they sometimes report strange experiences where the two halves of their brain perceive things slightly differently or at different times. Déjà vu could be a mild, temporary version of this. Your brain's integration system hiccups. Information gets processed twice. You experience duplicate perception, and your brain labels the second instance as familiar because it resembles the first instance, which happened 100 milliseconds earlier. To your consciousness, that feels like memory, but it's just an echo, perception reverberating through your neural architecture. Why it happens more when you're tired. Déjà vu happens more frequently when you're tired, or stressed, or sleep-deprived. Why? Because your brain's timing gets sloppy. When you're well-rested, neural processing is efficient, pathways are synchronized, information flows cleanly. But when you're tired, neurons misfire, timing becomes irregular, synchronization breaks down. And all these theories, dual processing, split perception, prediction errors, they all depend on timing. When timing is off, these errors become more likely. Your tired brain is more prone to processing glitches, more prone to misfiring familiarity signals, more prone to integrating sensory information incorrectly. Result? More déjà vu. This is why teenagers and young adults experience déjà vu most frequently. Their brains are still developing. Neural pathways are still being optimized. Myelination is still happening. The brain's processing speed is fast, but not yet fully refined. Timing errors are more common. As you age, your brain stabilizes. Pathways become more established. Timing improves. Déjà vu becomes less frequent. By the time you're 60, déjà vu is rare. Not because you've seen everything, but because your brain's timing has become more consistent. Fewer glitches, fewer misfires, fewer timing errors. Your brain has debugged itself through decades of experience. Stress also increases déjà vu. Stress hormones affect neural processing. They alter neurotransmitter levels, change firing patterns, disrupt timing. When you're stressed, your brain is operating in a heightened state. More errors, more misfires, more déjà vu. This is why déjà vu sometimes clusters. You have one episode, then another a few days later, then another. Your brain is in a dysregulated state, multiple glitches. Once your stress levels decrease, déjà vu frequency drops. Your brain returns to normal timing. Glitches become rare again. What about premonitions? Okay, but what about that feeling that you know what's going to happen next during déjà vu? Sometimes during an episode, you feel like you can predict the next moment. Like you've seen this before and you know how it ends. You think the person is going to say something specific. And sometimes they do. And it feels like proof. Proof that you've experienced this before. Proof of precognition. Proof of something supernatural. Except it's not. It's your brain's prediction system working normally. Your brain is always predicting, always modeling what comes next. During déjà vu, you're hyper-aware of this prediction process. The false familiarity makes you pay attention to your predictions. And when a prediction is correct, which happens frequently because your brain is good at predicting routine situations, it feels significant, feels like confirmation. But it's not. It's just normal prediction that you're noticing because déjà vu has made you hypersensitive to the feeling of knowing. Also, confirmation bias. You remember when your predictions during déjà vu are correct. You forget when they're wrong. Your brain preferentially encodes surprising or confirming information. Correct predictions during déjà vu feel meaningful, so you remember them. Incorrect predictions don't fit the narrative, so they're discarded. You're left with a distorted memory where déjà vu always feels prophetic. But that's selection bias, not precognition. Your brain is cherry-picking the hits and ignoring the misses, and building a false narrative that déjà vu has predictive power. It doesn't. It's just a timing error that happens to coincide with your brain's normal prediction functions. The simulation hypothesis. Connection. People love connecting déjà vu to the simulation hypothesis. The idea that reality is a computer simulation, and déjà vu is a glitch, the simulation running the same moment twice, or loading improperly. This is fun speculation, makes for good science fiction, but it's not supported by evidence. Every aspect of déjà vu can be explained by known brain mechanisms: temporal lobe activity, memory processing errors, timing glitches. You don't need to invoke simulations. Occam's razor applies. The simplest explanation that fits the evidence is usually correct. And brain malfunction is simpler than reality being a simulation. But here's why the simulation idea is appealing. Déjà vu feels like a glitch. It feels like reality breaking. Your perception fractures. For a moment, the world doesn't make sense. That feeling is deeply unsettling. And humans hate unexplained phenomena. We want answers. We want meaning. Just a neural one. And honestly, the fact that your brain can malfunction in this specific way is more interesting than simulation theory. Your consciousness is constructed moment by neural processes you're not aware of. Those processes can misfire, can produce contradictory experiences, can make you feel absolutely certain about things that aren't true. Déjà vu is proof that your sense of reality is fragile, constructed, dependent on timing, on neural synchronization, on memory systems working correctly. And when they don't, reality itself feels wrong. That's not evidence of a simulation. That's evidence that your experience of reality is an illusion created by your brain. And that illusion can break, frequently does break. And when it does, you get déjà vu, a momentary glimpse behind the curtain, a reminder that what you experience as reality is actually a model built by neurons, and models can glitch. Jamais vu, the opposite problem. Quick aside, there's an opposite phenomenon, jamais vu, never seen. This is when something familiar suddenly feels unfamiliar. You're saying a word you've said 1,000 times. Suddenly, it sounds weird, doesn't feel like a real word. You're in your own home. Suddenly it feels foreign, unfamiliar. You know rationally, it's your house, but the feeling of familiarity is gone. This is the reverse of déjà vu. Familiarity system malfunction in the opposite direction. Instead of false familiarity, false unfamiliarity. Your brain fails to recognize something it should recognize. The pattern matching fails. The memory retrieval fails. And you're left staring at something you know, feeling like you've never seen it before. Jamais vu is less common than déjà vu, but equally unsettling. It reveals the same thing. Your sense of familiarity is a function, a process, run by your brain, and it can malfunction in both directions. Too much familiarity? Déjà vu. Too little familiarity? Jamais vu. Both are errors. Both are glitches in the same system, and both show you how much of your experience is constructed, how much you rely on your brain correctly tagging things as known or unknown, and how disorienting it is when that system fails. What it all means. So what does déjà vu tell you about your brain? A lot. It tells you that your sense of reality is constructed, not perceived directly, but built, assembled, from sensory inputs, from memory, from predictions, from timing. Your brain is synthesizing a coherent experience from disparate streams of information, and when the synthesis goes wrong, your experience fractures, becomes paradoxical. Déjà vu is what it feels like when the construction process breaks down, when the seams show, when the model glitches. It tells you that memory is not reliable, not a recording, but a reconstruction. Subject to errors, subject to interference. Your feeling of familiarity can be triggered by things you haven't experienced. Your brain can convince you of things that aren't true, with absolute conviction. Déjà vu is a false memory, a memory of the present, and it feels completely real. If your brain can create false memories this convincingly in real time, what about your other memories? How many of them are similarly constructed? How much of what you remember is accurate versus reconstructed? Déjà vu is a reminder that you can't fully trust your memory, because sometimes it just lies. It tells you that consciousness is fragile. Your unified sense of self, of being present in a continuous now, depends on precise neural timing. When that timing is off by 100 milliseconds, reality fractures. You experience contradiction, paradox. For a few seconds, your sense of now splits. You're simultaneously in the present and the past. Neither. Both. Your consciousness is dependent on your brain's timing being correct. and it's not always correct. Consciousness is not this robust, reliable thing. It's a precarious construction, and small errors can destabilize it. Déjà vu is proof, and it tells you that your brain is always guessing, always predicting, always filling in gaps. You think you're perceiving reality directly. You're not. You're perceiving your brain's model of reality, and most of the time the model is accurate. But sometimes it's not. Sometimes the model lags, or predicts wrong, or processes information twice, and you experience the error as déjà vu. Reality hasn't glitched, your model of reality has glitched. And since your model is all you ever experience, the glitch feels real, feels significant.
Feels like the universe broke for a moment. But it didn't. Your brain did. And that's actually more interesting, because it means you live inside a simulation after all. Not a cosmic simulation, a neural one, running on neurons, and subject to all the errors, glitches, and timing problems that come with biological hardware. So here we are, déjà vu, the moment when reality feels wrong, when you're certain you've been here before, when your brain tells you two contradictory things and both feel absolutely true. It's not supernatural. It's not a glimpse of the future. It's not proof of parallel universes or time loops or simulation glitches. It's your temporal lobe misfiring. It's your memory system producing false familiarity. It's timing errors in neural processing. It's your brain glitching in a very specific, very well-documented way. And it happens to almost everyone, which means almost everyone has experienced their perception of reality breaking, has felt that moment of cognitive dissonance where what they know and what they feel contradict each other, has lived through a few seconds where their brain lied to them convincingly. And then it passed, and reality felt normal again. But you remember that feeling, that glitch, that moment when the model broke and you saw behind it, for just a second, before your brain patched the error and convinced you everything was fine. Déjà vu is your brain showing you that reality is not what it seems, that your experience is constructed, that consciousness is fragile, that memory is unreliable, that timing matters, that you're living in a model. And sometimes the model breaks, just for a moment, just long enough to remind you. Then it's gone, and you're back to trusting your perceptions, trusting your memories, trusting your sense of now. Until the next glitch, the next déjà vu, the next moment when your brain reminds you that everything you experience is a story it's telling you. And sometimes the story has errors.